By separating code deployments from feature releases, LaunchDarkly enables you to deploy faster, reduce risk, and iterate continuously. Over 1,500 organizations around the world use LaunchDarkly to build, operate, and learn from their software. Find out more at launchdarkly.com.
Hello and welcome to the InfoQ podcast. I'm Charles Humble, one of the co-hosts of the show and editor-in-chief at cloud-native consultancy firm Container Solutions. My guest today is Lucas Cavalcanti. Lucas is a principal engineer at Nubank, which is the leading FinTech in Latin America and has become the most valuable digital bank in the world. He gave a talk at QCon Plus in May of this year called Architecting Software for Leverage, and in it he described how Nubank's software, team structure and processes evolved alongside the various stages of the company, from startup in 2013 through growth, consolidation and expansion. I was really keen to follow up with him to talk about Nubank's programming language choices and their architectural choices because I found the talk absolutely riveting. As I mentioned, the starting point for this podcast was a QCon Plus talk. The next edition of QCon Plus is coming up this November, online and in person. As well as the incredible online experience taking place November the 1st through 5th, we'll have optional in-person events the following week in New York and San Francisco. Places will be limited. QCon Plus features 12 tracks curated by domain experts to focus on the topics that matter right now in software. Tracks covered this November include the cloud operating model, microservice patterns and anti-patterns, from remote to hybrid teams, and architectures you've always wondered about. At QCon Plus, you can find out what should be on your radar from the world's most innovative software leaders driving change and innovation. Each will share with you their solutions, best practices, and actionable insights to reduce uncertainty on which technologies should be part of your roadmap. We hope to see you online or in person this November. You can visit qcon.plus for more information. And with that, Lucas, welcome to the InfoQ podcast.
Thank you, Charles. Very glad to be here.
So in your QCon Plus talk, you mentioned that during Nubank's startup phase, an important driver was time to market. And then you listed some of your initial technology choices, which in truth, I found quite surprising. So could you maybe describe that initial technology stack with language, databases, messaging infrastructure, and so on, that you started to build on?
We are aiming for building a credit card product or eventually a bank. And on this financial domain, we started making some assumptions, right? So on that first assumption is for banking, we need to have the whole history, the whole audit trail of everything that we do. So the very first choice was the database, actually, the Datomic database, which was very niche. It is still very niche at this time, but it is a database that don't lose data on updates. So it keeps all the updates that happened on the data in the transaction log. So instead of storing the data, it stores the changes on the data, like a Git repository. It works like Git, like it stores the patches that you do on the entities instead of just replacing it. And what you gain from free on Datomic is that you get the whole history. And that seemed like a good property to have a FinTech at financial domain service. And Datomic is built in Clojure. So because of Datomic, we chose Clojure as the main programming language. We were going for a functional programming language. Either way, we probably would have gone to Scala or some other language if it wasn't for Datomic being Clojure. And these choices were mostly because we believed in functional programming because of the simplicity that it gets and also because of how we can connect it with financial domain, with functional programming relates very closely to mathematics and financials in particular. So also these were the choice. Other than that, like we aim to build everything in the cloud, so we chose AWS for that. And Kafka was a technology that was starting to get traction in 2013. And it had that property also of not losing messages. It keeps a log of the messages that you can replay again. And we also chose Kafka because of that. And the core of the decisions we took were mostly on getting the functional programming, immutability, and keeping data or not losing data, even on updates. This was what mostly drove our decisions.
So you said you were using Clojure. Did you use a microservice framework alongside it, or were you just using the language on its own?
Our initial stack in Clojure, we are surprisingly not using any framework or anything on the language. We were using a library for doing the HTTP server code, like the handling HTTP requests and so on. But we didn't feel the need of having like a framework or something like this that usually on other languages you end up using like Spring in Java or some like Rails in Ruby and everything. In Clojure, like just having an HTTP client library and an HTTP server library was enough for us, because they allow you to handle HTTP requests by receiving a map and returning a map. And that's simple enough and powerful enough for you to do that. So the service code didn't need any library, and the deployment code, which is kind of different. Clojure is Java, so we can use whatever Java has. So we basically initially bundled the code in a WAR file and deployed in a Jetty server in a AWS already baked image that contained a Jetty server that you could just configure to pull a WAR file from S3. So this was our initial deployment strategy. And at the very beginning, we only had like 4 or 5 services. So it wasn't that sophisticated in the beginning, but it was leveraging baked images on Amazon and CloudFormation to coordinate the deploys.
Just sticking with Clojure, had you used the language before, or was it new to everybody there?
I saw Clojure briefly on college. I had a functional programming class that I heard about Clojure there. I saw something about Lisp and like classes about Lisp. It's also like Clojure is based on Lisp. So basically you get around the syntax by learning Lisp, and Clojure is just learning the standard API over Lisp. But I never worked with Clojure when I started Nubank. So we saw the ideas behind Clojure. I already heard about them, but I only start really using Clojure when I joined Nubank. And that's the case for 99% of the people that join Nubank. Most of them, almost all of them, never worked with Clojure before. And Clojure is a language that's surprisingly easy to onboard with because it has very few language constructs, is parentheses and function calls. There's not much more than that compared to languages like Scala that you have like 100 language features that you need to understand sometimes. But in Clojure, you have like parentheses, like you have Lisp that we only need something a little bit more complex when you go to the macro world, but you almost never need to go to use macros.
So were there any sort of resources or books or that sort of thing that you found helpful when learning the language, or did you literally just pick it up?
I already had a functional programming background. I think like this is something that takes longer to understand or to learn. But if you already have a functional programming background, learning the Clojure syntax and constructs is something that you could do in a week. You don't need like to read tons of books or things like this. So there are some very good Clojure books that start appearing after we started using Clojure, not before. So, and we did several mistakes in the beginning on code style, on code organization Clojures, because we were basically using some of the other languages that we used before, like some Java organization or just some Ruby organization, and then don't fully apply to Clojure. And the organization we eventually came up with was very efficient and very much different from what we get from other languages.
Now, you mentioned as well that you started on AWS, on a public cloud infrastructure. And certainly in Europe, banking is extremely heavily regulated, which can make using public cloud a bit challenging. So I was curious as to whether that was also true in Brazil, and whether you hit any regulatory challenges as you were getting going.
We were a little bit pioneers of being a financial institution on the cloud. We did have some regulations in Brazil, or we had a regulation that had a gray area if you could store data about the customers only in Brazil, or you could do it outside or not. But the central bank in Brazil is an institution that was aiming for more competition and more innovation at the time. So they were willing to understand the usage that we had in the cloud and then start building new regulations and new rules for banks that were born into the cloud. Just to get a quick landscape in Brazil, like Brazil has only 5 banks that own 80-90% of all the banking services in Brazil, or at least used to be that way when we started. So the central bank was willing to understand new things and create new regulations. And being at the cloud at the beginning took some public policy work to talk to regulators. And we're pioneers, and after us, like there was like several other fintechs popping up in Brazil because of those regulation updates that happened because of us. Not just because of us, but we were pretty early on that movement.
You were pioneering in quite a lot of ways, I think. It's fascinating. What were you doing in terms of monitoring and observability at this very kind of early stage of the company?
Very early, we start using the Clojure ecosystem, like leveraging the Clojure ecosystem. So like there were a few tools in Clojure that allowed for real-time monitoring and transient monitoring at the time. So checking service state, checking like error rates over a small period. So it was not persistent at the time. I'm forgetting the name of the tool, but it was a Clojure tool that integrated nicely with the pedestal library that we were using for HTTP server at the time. We still use it, but this library integrated very well. So we started with this real-time monitoring, but transient monitoring. And we started to manage a Kibana log cluster for monitoring as well. And that ended up being more challenging than we were hoping for. And eventually we got to use Splunk, which is a log aggregator service. And that worked pretty well, and it's working so far. I think like the scale we are at, like took some challenges to get to the scale we are and use this kind of services. But I think like the monitoring in the very beginning was a real-time monitoring and a log aggregator. That was pretty much it in the beginning.
And in your QCon Plus talk, you mentioned briefly that you were using Alistair Cockburn's hexagonal architecture as kind of inspiration, which was obviously more object-oriented. But could you maybe describe what that is and how you applied it?
One thing to mention about the Cockburn hexagonal architecture is that it was born into a Java object-oriented world. And just to get a context, so what we use, it's not exactly that implementation, but it uses that idea as an inspiration. So I think like on the Cockburn's idea is like you have a web server, and at every operation on that web server is a port, and you have the adapter, which is a port that's an interface, and the adapter is the actual implementation of that interface, and the rest is like how do you implement the classes implementing that. The implementation, we use that idea of like separating a port that is the communication with the external world from the adapter, which is the code that translates that communication to actual code that you can execute. And then the controller is the piece that gets that communication from the external world and runs the actual business logic. I think the Cockburn definition stops at the controller, and after the controller, it's already business logic. Since we are working on Clojure and functional programming, we found it useful to separate pure business logic from impure in the sense of side effect business logic. So our controller layer is for handling side effects. And we have another layer, which is the core business logic, which is about just pure functions that receive maps and return maps or something like that. And that separation was very helpful for us. And I do have a talk that I can send a link here later that explains that breakdown on that hexagonal architecture that we use that has this separation.
That would be great, and I'll make sure I include a link to the talk in the show notes when the podcast goes out on InfoQ. But it sounds like it's kind of hexagonal architecture inspires rather than strictly hexagonal architecture.
And we even like gave a different name to not have this confusion about these ideas, to call it a diplomat architecture, which is inspired by ports and adapters, this hexagonal architecture. But it has this functional bias, the functional programming bias, of having every layer be as much functional as possible, or receiving maps and returning maps when possible, and not having any side effects, and keep the side effects on particular layers where they are more complex and you can treat them differently.
At its heart, this seems to be a set of architectural choices that are driven by wanting to have an immutable architecture, which actually, interestingly enough, is an idea I explored recently on the podcast with Matthew Perry. So I'll link to that in the show notes as well. But have I got that right? Is that what you're trying to do?
We are operating in a very complex domain. Like the financial domain is very complex by itself. And we got those ideas from the Clojure committee. Rich Hick has a very good talk about like simple made easy, which is the core of the Clojure language, which is we should aim for making simple constructs because the problem is already complex enough, right? So if you aim for simplicity, you don't have to solve problems because you created those problems. You solve just the problem you need to solve. And immutability is one thing that makes everything else simple because you have less things to worry about when everything is immutable. So we use that idea on the code design, like the architecture of the code we have on the services, right? So these ports and adapters, diplomat architecture aims for immutability on most of the places, but also the architecture, the infrastructure is also immutable. And this was an idea that was going on at the time, but it was not very much used, which is, okay, you're running on the cloud, but your machines are immutable in a sense that if you want to make any architectural change or any deploy or anything like that, you don't change a machine that's already running on the cloud. You always create a new one with the new configuration or with the new code or anything like that. So we use that immutable idea for the whole infrastructure as well. So every time we do a new change of architecture or changing configurations, it's always about killing or creating a new version of the system with the new configuration or with the new deploy. And when that's running, we kill the old one. And that also allows us to reason about the infrastructure with less entropy, with less things that can go wrong. Because if the new configuration goes bad, the rollback is easy. You just kill the new and keep the old one. You don't have to be tracking what manual operations you run on the services. You just, every new operations creates new machines and the old ones get decommissioned or deleted.
You obviously have some mutable aspects of the system. So how is that handled? In traditional hexagonal architecture, that would be in the ports. Is it in the database? Do you have an abstraction layer? How are you handling mutable aspects?
Most of the mutable aspects of the system belong into the database. I think like mutability on the system, mutable state, they are mostly on the database. But even the database that we use, the Datomic, we also call it an immutable database in a sense that it has a log of events that happen into it. And when you get a database, you get a value, a snapshot of the data. So it's basically when you get a database value, it stops the time. You don't get any new transactions on that value. So it's immutable in that sense. Like when you're using it, you do a checkout. If somebody else changes the upstream repository, it doesn't affect you, right? Until you do a merge. Datomic uses the same idea. You get a checkout of your data that doesn't change until you get the next version. So I think that's how we handle mutability in a kind of immutable way, because the actual transactions get a little bit safer because we don't have that state changing in place. The data changes, the entities change, but the data you get, the maps you get from the data, they are immutable. One thing that we didn't mention here, but like Clojure by default, all the data structures are immutable. So when you're writing your code, when you're writing your business logic, everything is already immutable. So you don't have to think about it. You don't have to do anything extra to get that. It's the language default. And that applies to the database as well.
So another decision that you took early on, which caused a lot of discussion actually after your QCon talk, was that you started with microservices. So typically, if you're starting up a startup, you would pick something that's quick to stand up. So the sort of classic would be a Ruby on Rails monolith or something like that. You'd build that, and then if it worked and you started attracting customers, you would perhaps move to a Java or JVM-based language and refactor to microservices. We've already said you started on with JVM, but you started with microservices as well. Why?
We started with the idea that we either succeed or fail miserably. So there's no midterm. Like if we wouldn't be a small size or a mid-sized company, it wouldn't make much sense. So one of the idea is like we believe that at scale, if the company grew for multiple teams or multiple places, the microservices architecture is an architecture that allows for you to have multiple teams and solve for a little bit of the organization between the teams. But that was not the only thing. We also had some restrictions on the data that we were saving. For example, we had customer data, which is personal identifiable information. And we assumed that we needed to treat it differently from the transactional data from the customer. So we also had that. And we had the authorization system that also would have a different storage requirements or database requirements. So the initial split in microservices that we did was mostly because we have that heterogeneous storage requirements for different kind of data that we had. So we had customer services that was designed to store personal information, and therefore we'll have like encryption at rest or enough encryption so we don't leak customer data. And we had the transactional data that was going to need scaling requirements differently and everything. And we had the authorization data that also had a different requirement. And those were the three first services that we had. And we had a fourth one, which was geolocation service, because for the signing up process, we need to get like zip codes, and zip codes had a database for that. Anyway, like the initial decision that we had on separating in services, not necessarily microservices, but having a service split into the architecture was because of these different requirements on storing data, which we could do in the same database, but it's harder to do it on the same database when you have different scalability or different encryption requirements.
And then after you launched, you went through a very rapid period of growth from about 2015 through 2016, which I think was a lot faster than you anticipated. So what were some of the challenges that gave you from an architectural point of view?
One of the major things that happened at the time is we started leveraging a third party to run the credit card system. So we didn't build a credit card system from scratch. We basically bought an off-the-shelf credit card processor system. And from the projections that we had and from the initial conversations, we could live with that processor for a few years before having to bring everything in-house. So the first surprise that we had is that we had to build a full credit card system to go out of that processor much earlier than anticipated. So the first architecture thing is how do we migrate a third-party system and in-house all the features of it? I think that was one of the first challenges. And it works like breaking a legacy system or all those behaviors that we see on that are very challenging architecturally and on the business side as well, bringing every feature in-house. And also our initial architecture for deployment also didn't scale before we anticipated, right? So we had an architecture that could fit 500,000 customers easily. And we thought that we could live with that for also a few years. And we hit the target 1 year later or 2 years later than we anticipated. And we had to start a sharding project because of the initial choice that we had on using CloudFormation on AWS. We didn't have Kubernetes at the time. We didn't have Docker at the time that we started the company. And basically the company grew faster than we could run the project of migrating everything to Docker or to better structures on AWS. So we could do a sharding project. And this charging project was basically, we started having the customers' data in the same shard, but we could have another shard with a different set of customers and all the data on that shard. That was the decision we had on sharding. We separated by customer. Anyway, this was one of the things that we started leveraging the cloud, that you can vertically scale, or some pods, you can horizontally scale some pods, but eventually we reach a limit. And we had to do this sharding project because we do have that limit on the cloud. It's not infinite. And we had to do that much earlier than expected. And when we really finished the charging project, the first shard was bigger than it should be. And that created some problems after, but that created several challenges on scalability later.
So you said you were sharding by customer. You said already that your kind of initial shard was unexpectedly large. I'm imagining there must be a lot of edge cases if you're sharding data that way. For instance, different amounts of activity by account or whatever. So did that choice throw up some kind of more unexpected edge cases, things that you were not anticipating when you made the decision?
Yeah, I think eventually we learned that not just the number of customers is a factor, but also the tenure of that customer, and the fact that the very first customers of a startup are the early adopters, are the ones that use the product the most. So this first shard ended up being a special shard for a while because we had the most passionate customers that use the product a lot. We had more data, more novelty, and we had more customers on that shard because we took too long to implement the sharding project. So, for example, all the provisioning on that shard was 4 times, 5 times more than the other shards that we created afterwards. Eventually, we could make all the shards about the same size, but we did have to do performance fine-tuning on that first shard. And the whole idea behind doing sharding at the beginning was to not do any performance tuning, because optimization code tends to be a lot more complex than non-optimized code. Like if you're optimizing for humans, it's very different than optimizing for the machine. So we ended up having to do optimizations because this first shard is or was special for a long time.
Right, yeah, but actually, now you say that, that's not surprising, but I can imagine why you would miss it. And you said as well that you switched to using Kubernetes for container orchestration. So how did you go about that? Are you using EKS or a service, or did you do it in-house?
When we started using Kubernetes, there was no EKS, at least in Brazil. That's what you get to be on the early adopting phase of technologies. We did that for Kafka, we did that for Docker, we did that for Kubernetes. So when we started, there was no cloud solution for that yet. AWS didn't have a Kafka cluster back then. AWS didn't have a Docker container or a Kubernetes service. And eventually, now it does. So if we were going to start today, we would do probably everything on the cloud or using a cloud service for that. But we started doing our own Docker registry and eventually migrated to the AWS one. We did our own Kubernetes cluster, and we are still in the process of migrating to the Amazon service. We saw the potential of those technologies, so we felt that it was worth it to be an early adopter or early enough adopter of those, but we paid the price to do an on-premise solution before we had a cloud solution.
And presumably as you're scaling up, your data needs are changing as well. You said you use Kafka already, so initially I was thinking, well, presumably you use Kafka Streams now, but I'm thinking, were you too early for Kafka Streams as well?
By the time that Kafka Streams went live at production, we already had our own Kafka style of using, and if I'm not mistaken, we already built an ETL pipeline to transform the data into a Spark cluster. So basically, since we already had to do that, it didn't make sense to use Kafka Streams anymore. or at least not in general. I think it might make sense for specific cases, but not for having this aggregated data. And because of this sharding and microservice architecture, like we have two splits of data. The first one by services, so every service might have their own database. And we have shards, so every service have multiple copies of databases. So we needed an aggregator system that could get all the data about all the services in all the shards, so analysts could run queries and do analysis, or all the other functions in the company could access that data which was split. So we did need to run that ETL process. And by the time that we needed to do that, Kafka Streams was not ready and we didn't use it.
We've mostly been focusing on the back end, but just out of curiosity, where you are now, what are you doing in terms of the mobile and front end? What does that technology stack look like now?
That also evolved a lot over time in the company. Today, the new code, the new thing that we are using is on Flutter. We're using Flutter plus Dart to write new code that can run in both operating systems, right, like in iOS and Android. But over time, we had several technology shifts on mobile. We started with almost full native, and by the time that React got some tractions, we started a little bit with React Native. We did some changes over time to eventually get to Flutter, but we didn't migrate the whole app yet to Flutter because it takes a while to do that. We still have some code with the previous technologies that we use. But today we are leveraging Flutter. I'm not a mobile developer myself, I'm a little bit far from that, but it seems to boost a lot the productivity. We do that with a design system as well. So the Flutter technology plus having reusable components that already have the company's look and feel, and it's easy to plug into that. This boosts a lot the productivity, and we don't need mobile specialists to do that. We can have generalists doing mobile work, and we do have mobile specialist team that builds the components for that design system and that Flutter. We do have reusable components that a mobile specialist team builds, and then generalists can use that in a simpler way or in a way that you don't need to have too much mobile context to do.
So it's not often that you get to do a startup from the very beginning through hypergrowth to the point that you've reached now. With the benefit of hindsight, are there any sort of one or two things that, knowing what you know now, you would do differently?
One thing that we underestimated about the system is that financial services are a regulated industry. So we took several choices that affected the day-to-day operations of the system, so the production environment. But there was some choices that didn't work that well on the analytical environment, right? So we made some clever code that did some automatic fixing of invariants for the system, which then it's a thing that's very hard to replicate on the analytical environment later to see why that system self-corrected that way. And we did have some implicit operations going on. And by the time it felt like a good idea, for example, you have an accounting system from an account that should never go negative. And when it goes negative, we had a code that self-corrected it and make sure that that was never negative. But then this is something that only exists on the memory of the machine that ran that code. We don't have traces for that particular correction. And that ended up harming us a lot, the ability of explain things that happened. So anyway, that to saying what I regret the most is to have implicit operations that are not stored to the database or that don't have origination information. That was one of the early mistakes, the major mistakes that we had. And also not documenting decisions and architecture decisions and design decisions that we had. and product decisions. Like on the first years of the company, we barely didn't document anything. Not just the code. I think like we did have like the documentation on the code and everything, but the most important things were the decisions. The decisions exist only on my head and a few folks that were in the beginning of the company, and not having that documentation, it hurt us like few years later when we scaled to several teams and when the company grew big enough that people with no context don't know why the decision was there, and doesn't scale for me to explain everything to everyone every time, right? So I think like these was the two things.
Yeah, I think having an architecture decision log is one of those things that often gets missed. It's really valuable. Lucas, that's great. Thank you very much for joining me this week on the InfoQ podcast.
Thank you very much.